Yeah, that was impressive. Ah, hey, we have slides. That's cool. Remind me to never do that again. Oh, Jesus. I don't get younger, I guess. Hey, how are you doing? Yeah? Having a good time? Whoever was slow clapping over there, I heard that. I'll take note. I'll have you, I see you. Just saying. All right, so let's get into things real quick. So we're going to talk about VR and AR and XR and all these wonderful acronyms. And it is a bit of a hype. VR has kind of like done half of the hype cycle now. AR is up and coming. And there's a lot of overexcitement, maybe. There's a lot of weird marketing speech here and there that might make things a little blurry. And everyone wants to get involved with VR, including a Portuguese insurance company that does these wonderful advertisements. And I'm not really an expert on traffic security, but I would say this is, my clicker died, this is a really bad idea. Don't drive in VR at the same time, okay? Just making that sure. Maybe this insurance is actually not an insurance, but like a car mechanic or someone, or like a doctor, I don't know. Do you have to pay healthcare bills in Portugal? I don't know. So yeah, let's have a look at what this all thing, like this entire topic and this entire scope means. So there are a few, I don't know why you're laughing. I've never seen these slides behind me ever before. No, just so like there's a few, acronyms that are out there, and they might be a little confusing. So let's have a look at what they mean. And for this, I'd like to introduce a spectrum. So we here in this room right now are in the real world. That's going to be on this end of the spectrum. I know it's shocking, right? And Elon Musk probably disagrees and says, no, actually, this is a simulation. I don't know about that, but I think for what we know, this is the actual reality. So we can only perceive what our natural senses let us perceive. We can hear the rest of the room. We can see the rest of the room. We can hopefully see me as well. You can hopefully not smell me. That would be weird. But basically, like, we have what our nature has given us in terms of perceiving our surroundings. And we are in this current context. And we know that we are in, hopefully we know that we are in Vienna, we are in the Austria Center, we are at WeAreDevelopers, it is 2018. Yes, I know that's shocking news to some people, but yes, it's 2018 now. So this is this end of the spectrum. But then, a lot of people, when they talk about virtual reality, they mean actually virtual reality, they mean actually like this, somewhere on the spectrum. And the next thing on the spectrum is augmented reality. So what happens if we take our phone out? We now have additional information. So if you, for instance, use a Maps application on your phone or on your computer, you might see things that you don't really see or know things that you don't really know, like where's the next restaurant? Or where's the next, or how long does it take me to take a car from here to the main station, or something like that. So we are enhancing what we can perceive and what we can know by using technology. And augmented reality, in the strictest sense, means that we are basically allowing us to visually or audially or oral, like olfactory enhance our senses. So for instance, you could have a piece of glasses that show you, when you look at someone's face, who that person is. I'm saying that theoretically you can know this, but I'm really bad at names and faces. So this would be one of the augmented reality applications. Or maybe it shows you, if you're in the mountains, it shows you the name of the mountain, or it shows you the next hut that you can go into. So basically, you're taking additional information and put that in the context of where you are at this point in time. So for instance, if I have an application that shows me where to go to the other stages, because this venue is a bit of a maze, isn't it? I mean, it's amazing as well, but it's also a maze, like quite literally. So if you have a thing that lets you figure out where to go and how to get to a certain stage, that augments your abilities. So it's augmented reality. It takes the reality that you're in and puts additional information on top of it. And then we have what used to be called mixed reality. So mixed reality would then be like somewhere in the middle of this. So it's a step further, where in augmented reality, the objects that we add to our current situation or our perception do not really interact with things. So if I, say, have an application, an augmented reality application, a classical one, that lets me try out furniture on the stage, for instance. So I can basically say, yeah, this couch would look nice. I would like to have a nap on that right now. then that couch would just like hover there in space, but someone could like walk through it, which is not something that happens in reality. So you can really easily figure out that this augmented reality layer is actually not interacting with the reality. However, what happens if I have an application where, let's say I have a ball, a soccer ball, and someone could walk up to it and kick it, and it actually flies, like the virtual ball interacts with the reality around it. That's what's used to be mixed reality. However, a certain company from Redmond thought, we're going to make new products, and we call them mixed reality. I'm not going to name any names. It's a part of many rooms. So if you ever had like a good view from a window, that company decided to rebrand the term a little bit. So if you hear mixed reality today, it oftentimes means a platform that works both with virtual reality and augmented reality. Now I said a word that isn't on here yet. So then the next step would be virtual reality is on the other end of the spectrum, and basically we ignore where we are. We completely like fade that out and go somewhere else. So if I now put on a VR headset, I might think that I'm on the Maldives, lying on the beach, and hopefully having a drink. That would be nice. I might just have a VR headset that allows me to go back in time, like visit ancient Greek or Roman cities from like 2,000 years ago. I hear time travel is still pretty expensive these days, so that would be an interesting thing. So VR basically ignores our surroundings while AR takes them into account. Mixed reality was somewhere in the middle. Now it's used as a marketing term to encompass everything. But there's another term that encompasses everything, and that is XR. It's extended reality, or X as in like a placeholder for VR and AR, depending on what you do. So this usually leads to people asking me an interesting question, which is like, hey, Martin, now that AR is out, do you think VR has lost the game? Or do you think VR is better than AR? And I'm like, I don't know. Is a carrot better than a potato? Is a hammer better than a screwdriver? They're different things. No, it's not. That's wrong. Just if you said yes now, reconsider your life choices. So like there's this conception or misconception that AR is competing with VR or vice versa. But actually, I'd like to think of it differently. VR brings me somewhere else where I can't be right now. Whereas, for instance, like a teleporter would do, right? So like if I wanna join a meeting somewhere in San Francisco right now, that's a little tricky because I gotta run to the airport and then I gotta get on the flight, and it's going to be ridiculously expensive because it's a last-minute flight because I completely did not plan this. So it's not really nice. But just having like a video chat in front of me might not really do it because I might not get the perception of like people's gestures and facial expressions when they are somewhere where the camera can't see them. But if we would have a 360-degree camera and it would be like sitting in the meeting, then I get the full bandwidth of expressions from everyone around me as if I would be sitting there. So it takes me out of where I am somewhere else, right? So that's what VR does. That's the tool that it provides us with. Whereas AR is actually bringing something to where I am right now. It adds to the current situation that I'm in. It doesn't take me out of this situation. So it's more like a lens or X-ray goggles. It lets us see or perceive things that we can't naturally perceive at the situation that we are right now. So basically, it adds information. So you can imagine, if you look at it like this, you can imagine a hypothetical device. Let's say I have to work, I don't know, I have to work in a city that I'm not used to. I have to fly to a city somewhere where I don't speak the language and I can't read the characters. I can't read the scripture. So I have no idea what the signs say. I do not know where I have to go, and I have no overview of where I should be when. But then I have glasses that tell me, hey, bidding, hey, you have to, go out of the hotel, turn to the right, go into the metro station, and take that one line that I'm showing you. And then you hop onto this metro, and it says you're now riding this metro for 45 minutes to get to your destination. Metros, some people like them, but some people don't. I'm not very fond of being stuck in a metal tube with lots of people that I don't know and that have very different degrees of hygiene standards for themselves. So I might want to not be in this situation, right? I have to be 45 minutes on this metro, but I really, really don't want to be in this situation. So I can't physically, subtract myself unless I would exit the train and then miss where I have to be or not get where I have to be. So what I could do instead is I could switch my goggles to VR mode, where they completely, shut out what is happening around me and let me perceive that I'm somewhere else. Maybe in an interesting movie where like things are happening around me, or maybe a game or whatever. So I can take myself somewhere else. I can teleport myself somewhere else. And then the glasses know, aha, in 5 minutes you have to go out. So it like lets me know, hey, by the way, this is your stop. Please come back. And then you're like, all right, okay, cool, fine. You tap your glasses or whatever, or just like think about it because it's a magical future device that doesn't exist yet. So, and then it takes you back to where you are, and then you like follow the instructions and you get to this point where you have to be and meet someone or whatever, right? So these two do not conflict with each other. They complement each other. They are not antagonists. So XR encapsulates all of this. So if I'm saying VR, I mean virtual reality. If I'm saying AR, I mean augmented reality. If I talk about XR, I mean either of these. For me, it's a catch-all phrase, basically. All right, blah, blah, blah. But like, that's all cool, but what can you actually do with it? Like, okay, games, great. Maybe movies. But I'm not working in the games industry and I'm not working in the movie industry. So what on earth can you actually use this for? So that's a really good question. Thank you very much for asking. So one use case would be in education. There are relatively cheap ways. These are Google Cardboards. So you can use basically $5 cardboard cutouts with a phone, with a smartphone that is not a potato, basically. So with a more or less recent smartphone, you get the capabilities to really cheaply get a really cheap version of VR, and you get to like take classrooms somewhere else. It's now also available for Daydream, and as far as I'm aware, Google does a lot with like various schools around the world. It's called explorations or something like expeditions. That's what it's called. So you get like virtual tours of other places with educational content. You learn about climate change, you learn about politics, you learn about the refugee crisis, you learn about history. All these kind of topics can be tackled and visualized and brought really close to students across the world without having to actually take the students somewhere else. Especially with like ancient Rome, as I said, it's pretty expensive time traveling these days. I wonder about the carbon footprint of time travel. Anyway, I distract myself. So this is actually a really cool way of getting people a more direct way of experiencing content, because you can read about it in a book, cool, but it might not be as direct, as impressive for you and as remarkable for you than it would be in virtual reality if you immerse yourself to it. Then we have healthcare. And in healthcare, there's actually two larger categories of usages. One is for theoretical applications, and the other one is for training. So there is a study where they talked to burn victims, if you wish, like the large portions of the skin have been burned, and the physical therapy is pretty painful. Now, pain is something that is relatively subjective, but you can still sort of measure it. And so what they tried is, what happens if the physical therapy happens while you're somewhere, like we trick your brain to be somewhere else, in a more pleasurable spot, maybe, at a beach or wherever. So it turns out that it can actually reduce the pain that is subjectively felt by the patients that undergo this therapy by 25%. So we trick our brains into relief, which is pretty great. You can use this to treat traumas as well as like help patients recovering from phobias or other other mental disorders and traumas. So that's pretty cool. But you can also use it as a way, for instance, for surgeons to try certain procedures before they actually do them. And again, it tricks our brain, and so we feel the same stress, we feel the same anxiousness, and we feel the same pressure, and we actually get to like physically do something, but we are not actually doing it. We trick ourselves into doing it. So that has a great benefit to training purposes in medical applications as well. So that's really great, I think. Now, you might not be in education or healthcare, so let's have a look at a few more. How about tourism? So here we trick someone into believing that they are somewhere where they actually aren't, again. And you see this reaction, you don't get that much reaction from just showing a video of a camera filming from a helicopter these days, right? That's because we trick our brain into believing that we're actually there. So that's pretty cool. And related to tourism, there's also marketing. You can show products more easily. You can do the try before you buy, but you don't have to physically try it beforehand. You can like trick your brain again into thinking that you've got the thing, and maybe you try on clothes, or maybe you try out a car by sitting in it and trying it out like that. So that's pretty cool as well. You can use it for design and engineering applications, so that's more the AR part than the VR part, probably. So you can hover over real existing hardware and then like see what each part is, and you can work on it manually or maintain it. You might as well use that for designing new things where you don't have as much information available as you need to like try out different designs. So that's pretty useful. Intel and Coca-Cola use this in their various logistics. So they figured out that they can like save like 10% of the effort they usually need. Like they're performing 10% better in terms of bottom line at the end of the year. So that's pretty good by just using AR. In arts and entertainment, you can explore things that you can't normally explore. So like there was someone painting with fire. I don't know how often you did that. My mother was strictly against it when I was a child. So that's pretty cool. You can also paint with water. You can paint with music. Or you can paint with colors that are responding to music. I remember that you had to take a few substances to get that going beforehand. So that's like probably cheaper and maybe healthier. All right, so we have a bunch of use cases. So I would say it's not really like just one vertical. It can affect many, many verticals in one go without like touching, too much on them. So that's convincing. And then if we have a look at the VR landscape real quick, so there's like the HTC Vive, for instance, that's around 500 euros. It's like the high-end device together with the Oculus Rift and many of the Windows mixed reality headsets, like the Samsung Odyssey. It's more or less these prices. I think like the Samsung Odyssey is like 250 euros or something. Then we have mobile devices such as Gear VR, or here pictured Daydream. They're around, actually the Daydream is cheaper. The Daydream is like 50 euros now. I forgot to update that one. And then we have the cardboard that's still around. It costs like nothing. So you have to have a phone, sure, but hey. And in 2017, they sold more or less like this. So we have the Oculus and the HTC Vive, a little under 1 million devices. Like that's not the ones beforehand. It's not cumulative. Just in 2017, approximately 1 million Oculus and 1 million HTC devices sold. Approximately 2.5 million PlayStation VR devices. So that tells you that there's like something in entertainment that makes it go well. And then a little more than 2 million devices, Daydream devices have sold as well. And we have approximately 3.5 million devices for the Samsung Gear VR sales, just 2017. There's many millions more before that, and hopefully after that. But there's one player missing here. That's the cardboard, and I used to have a different graph. I'm not doing this anymore because it's misleading now. So basically, just in 2017, we sold approximately 3.2 million cardboard devices, but there are already 82 million. So like the cardboard is by far leading, even though it doesn't look like that. But what I want you to see is the high-end desktop VR sector that is tethered to a computer is not like the biggest market. The biggest market is in mobile. Actually, these three, really. So the market in mobile is larger than the market on one particular desktop device. But they are all using different platforms. So you would have to build native applications for each of these platforms to get all these together, right? Well, how about no? So let's have a look. Let's have a look. Who here has a Windows computer? Okay. Jesus Christ, the light is really bright. I have to walk out of this first. Okay, so again, Windows computer. All right, Mac OS. All right, Linux. Yes, thank you so much. That I need to, all of them have to come back later and take a picture with me. Anyway, who here has an iOS device? Who here has an Android device? Who here has a Windows mobile device? There's a few. That's cool. No, don't laugh. This is really cool. Like, that's cool technology. Just Jesus Christ, people. So who here has an Oculus Rift, HTC Vive, Samsung Gear VR, any other VR device? Who here has a browser? That's pretty good. So yeah, congratulations, you are VR ready. How do we do that? Well, not too complicated, really. So there's two technologies. There's WebGL, which does the 3D rendering in the browser. That has been around since 2011, so we are actually kind of doing fine with that one. And then there's the relatively new WebXR standard. That encompasses AR and VR on the web, and is relatively new and still in development, but a lot of browsers already support it. That's just really nice. And what the WebXR actually does is it gives us access to the headsets, if there are any, or if it's like an AR-enabled phone, then you get that exposed, so you can figure out if you have these capabilities in the browser. You get the orientation and position, so if you have a Gear VR or a Daydream or a cardboard, then we don't really know where in the space you are, so you only get like where the person is looking at. But this kind of information gets exposed, so you can like let the user walk through a virtual world. You get the position if it's available, and you get the orientation of the user. It also exposes additional game controllers that come with some of these devices, so you basically have like everything that native has really available in the web through JavaScript. That's pretty good. These are the browsers that support it at this point. So Chrome is hopefully soon landing it for desktop. So far, it's only in the Chrome for Android. Chromium, there is an experimental version that you can already use. Firefox has it in stable and nightly if you want to try it out. There's Edge supporting it. There's Samsung Internet supporting it. Oculus Carmel is an experimental browser. And the last one is Servo, an experimental browser from Mozilla. So they support this now, today, as we speak, which is pretty great. Right? So not too bad. This is how you get started. No, no, don't worry. I'm just screwing with you. So the problem is I had to switch laptops, but it's the internet, so I hopefully can do something on a computer that is absolutely not mine and uses a different keyboard layout, but that's going to be great, right? Okay, let's have a look. How are we doing here? So, no. Can I not just start with something? Come on, give me a thing. Come on, glitch, don't be like that. Hello Express, no, hello web page, that might work. So what happens if I say remix my own? Yes, I get the possibility to do this. So there's a library from Mozilla that I would have totally prepared, but again, laptop literally changed seconds before my talk. So what I'm going to do is I'm going to steal a bit of HTML from this wonderful website, as you do, because great artists steal. That's not to say that I'm a great artist. I'm just a thief. So what we have here, and I hope that I can zoom in a lot. Let's see how this reacts to zooming. Hey, that's actually not too bad. Go away. All right. So here, what we write is we write a bit of HTML, and what we do is more or less like a movie. We have a stage, a scene that is empty. And we have a camera, which is the eyes of the user. And we can position this camera by the user pacing around. And then we have objects that we put on top of, or in the scene, so that we can see it. So here what we are doing is we put in a box, and a sphere, and a cylinder, and a plane, and the sky, and I'm going to delete all of that. Because, that's too much stuff here, really. It's like, let's start simple. So let's start simple. Let's start with, let's see. Oh, Jesus, different keyboard. So I start with a box, and this box is at the same position as the camera, so right now we are not seeing it because we are kind of like standing inside the box. Nope. This keyboard is weird. Okay, so I'm going to move this box not to the left or to the right. I'm going to move it 1.60 meters up, because if I don't have any size information of the user, because I'm not having any headsets connected, it's 1.60 meters. It assumes that the user is approximately 1.60 meters, because that's a good approximation, I guess. And then I'm moving it -2 meters out of the screen. So I'm moving it into the screen, which is where the camera by default looks at. And if I now do this, then it doesn't do much. That's smashing. Oh, right, it's white. That's why. Yes, sure. I keep forgetting that. So let's give this one a color. let's say red, and it reloads, which is nice. Hey, least exciting VR demo ever. But the nice thing is, you can just like cut it out, really. Can you like not be sarcastic or something? Okay, cool. So, but the nice thing is it automatically does what responsive web design does as well. Like, we have adapted to like, oh, the device factor is different. So it does that as well here. It goes like, there's no VR device as far as I'm aware. So how about I just give you like keyboard controls so you can like walk around, and I give you mouse controls so you can look around as well. So I get that for free. That's pretty cool. On mobile, I can use either like move my phone around, or I can use swiping on the screen. But what's even cooler is the developer tools that are built in. So I don't have to go to the code and like do all of these visual things very manually. I have these developer tools that help me. So these developer tools are built into A-Frame. And then, I know it's shocking, right? You lose your water bottles. So I get to like manipulate the scene from right here. So I get to like move this block around, and maybe I don't like the color. Maybe I go in here and change the color real quick. So I change this to like bluish. And then I go back, and this thing is in a different position, and it's bluish, and I can rotate it as well. So if I want to rotate this one and maybe scale it as well a little bit like this, I can do all this, and then I can basically just go here, scroll up a little bit again, and say like copy this. And now I go in here, and I say, hey, hi, how are you doing? Can I please like paste this in here? And et voila, it has reloaded, so it has taken my changes into account. And I can add new things as well. So I can add a new entity here. I can move this entity around. And you see, like, entities are these objects, but they are not visible, so I have to attach a geometry. And this is a component model, so that means I get to write my own components. Here, in this case, this is a geometry component, so it offers me a bunch of geometries. Let's say, for instance, like torus knot. So now we have like this, I call it the pretzel of 3D. So yeah, you get to explore things very, very visually. And there's a little button, and if I would have a VR headset, I could press it, and then I would be in VR, which is really nice. And it's responsive. So all of you with a browser can explore this content and can like build stuff with it. It's HTML in the end, right? But it responds to the situation that you're in, and it responds to the device. Cool. You can also embed like 3D models from artists. I normally have some on my disk, but not on this computer. But if you're interested in seeing more, tomorrow at, I don't know, 1 p.m., I think, I'm going to do a workshop. What? OK, right. I'm going to do a workshop on this topic. So if you want to see in a more hands-on way and have already registered, great. If you haven't registered, good luck. I hope that there might be some spaces still available. But definitely approach me on this kind of stuff, because I'm really excited about this. So this makes it easier for people to build stuff with it. You can also use AR. I just want to real quickly show you this. So this is in a real-world situation, right? We are somewhere in Zurich. We are selecting the walls here. So like this. And with that, we can then, so we have now physical positions in the real world. We say this is a door, and then there's a door here as well. And then we can get the floor plan. And we can say, hey, computer, can you furnish this for us as a living room? As an API call. That's it. That's not WebXR. That's stuff that my previous employer built. But it's open source and pretty cool, in my opinion. So you can basically just like have the computer do some machine learning and go like, living rooms with dining tables usually look like this. And this is what fits the room. So you like get to like try this out. And this is in a browser. This is an experimental browser here, but this is live on a browser. So if you have a phone that supports this and this experimental browser, next week, Chrome Canary, if you have a Pixel phone or a latest Samsung phone, then you actually can install the Chrome Canary build and get this kind of stuff in your regular browser. It's happening today. OK, yeah, whatever. Keep building. There are a few challenges when it comes to like input. So you might think that like what looks intuitive when it comes to like input methods might not be intuitive. and it might not be the best user experience. So you want to reconsider that. You want to have a look at how you monetize your content, because some of the old models don't necessarily really work that much. So you might want to reconsider that as well. And also performance is a thing. So 60 frames per second on the web are cool. 30 frames are meh. And for WebXR, you want to kind of hit 100 frames per second. And that's possible with a request animation frame that WebXR exposes. 60 frames is still pretty good. In AR, that's fine. But 30 frames per second, how do I put this? Might have an impact on the user. Right? So make sure that your performance is on point. So please have a look at the resources. There's a A-Frame School, which is an interactive tutorial. There's a sandbox that you can play around with if you want to see like the API that I showed you to furnish things. There's a bit of videos that I used to make, and there's like a blog that you can check out. And please, I'm on Twitter. Tell me what you build with it, because I'm really excited to see more people getting into this. And with that, one last thing, and then I'm finished, I promise. So Steve Jobs said, if the bicycle was augmenting our abilities, then the computer is like the bicycle for our minds. And I say, if the computer is the bicycle for our mind, then VR is a teleporter. And I tried to find a quote, but I couldn't. So you now have to quote me on this. Thank you so much. If you have any questions, please find me. I'm probably around the Google booth here. Please talk to me and other people. And now stay first for the next talk, because it's going to be great.
Thank you, Martin.
Thank you.